Okay, section 10.3 or 10-3. And we are into chords. Okay, learning target today is going to figure out what is a chord. All right, a chord is a segment that has two endpoints on a circle. Okay, so we have AB is a chord. C-H-O-R-D, chord. And arc AB is the contained arc. Okay? So if two chords on the same circle are congruent, then their contained arcs are also congruent. So if, and we'll say if the arcs are congruent, it's biconditional. If arc AB is congruent to arc CD, then AB is congruent, segment AB is congruent to segment CD. Okay? So a chord So a chord is a line segment with both endpoints on the circle. They have to be on the same circle. Just so happens that a diameter is a chord. The diameter is the longest chord. So if you think about it, you can't get any longer than going straight through the middle. Okay, diameter is the longest chord. I'm sure you remember that. Now, there's something called a secant. The secant is a line that passes through a circle. So a tangent, remember, touches at one point. A secant touches at 2 points. Now, therefore, the chord is a portion of the secant. So a secant is the line that goes through it, and the chord is the segment. So if we look here, and if we were to draw a secant, so secant AB contains chord AB. Okay? Now, what's really cool about this is, if you have two secants in a circle, CD, and those two secants happen to be parallel, okay, so if our secants are parallel, then they each contain congruent arcs. So if we notice, if this is X, and these two are parallel, then this has to be X, and based on our inscribed angle theorem, then BD measurement has to be 2x, and this one has to be 2x. So the arcs between secants, or parallel secants, are always congruent. It's not talking about the backside CD or AB. I'm talking about AC and BD have to be congruent if the chords are parallel. So parallel chords contain congruent arcs. That's kind of cool. And remember, chords are the segment portion of our secant. All right. Now, the next thing you need to know about chords is that when you take a chord and you do the perpendicular bisector of a chord, so remember, perpendicular bisector of a chord, it's always going to pass through the center of our circle. And that is a very poorly drawn circle, but pass through the center of our circle. Okay? All right? So, what is cool about this is that we always have a right angle here. Okay? So if you know two chords on a circle, you can always find this. If you know two chords on a circle, you can always find the center of the circle because we do the perpendicular bisector of both chords. Now, the next thing to know about chords is if I know the distance between the chord and the center. Here's this part. So if I know the distance from the chord to the center, and I have another chord, okay, so that's, this side is 2x, and this side is x, okay, I know that CD is going to be bigger than AB because the closer the chord is to the center, the closer it is to being the longest chord. So the further the chord out is closer to the edge, it's going to be it's going to be longer. So if the chord is the same distance away from each other, so if chord CD and chord AB were the same distance away from the center, they would have to be also congruent because of you could do side-side-side triangle congruency and show that. Okay, but the biggest thing is knowing that the perpendicular bisector of all chords, pass through the center of the circle. Okay, like I was saying though, if you have a chord, if we know that chord AB and chord CD were both 2 away from the center of the circle, 2 inches, then AB would have to be congruent to CD because they're the same distance away from the circle. This distance away from the center. So if you were to do this, we know that this distance, we know the radius doesn't matter, it's x, and we know that this angle is 90 degrees. So therefore, we know x, and we know 2 parts of the right triangle, means we know the triangles are congruent. All right? And that's about chords.